Hello all, good evening. This is Kumar Ankit present here with to share some of my learning experience on how to implement a logistic regression in dataset. So rather moving forward that how to implement a logistic regression in dataset, let us have a quick review that what is a logistic regression. So logistic regression is a classification problem. So in logistic regression, it produces a result in a binary format which is used to predict the outcome of a categorical or dependent variable. So the outcome should be in discrete or categorical such as 0 and 1, yes or no, or true or false, or high or low. So having a quick preview on what is a logistic regression, let us see that what are the steps that we should follow to implement a logistic regression to any data set. So there are 5 steps that we should follow. That first is the collecting data, second is for analyzing the data, third is for data wrangling, fourth for data for test for training a data and then testing it, and then fifth is for the accuracy check, that how my model is performing or how my model is behaving on top of that. So while doing all that is the first process is collecting a data. So importing all the necessary libraries that I need in that I need. So importing a pandas, importing numpy, matplotlib, seaborn, and os and maths. So after importing all the library, we have to read a data to a Jupyter notebook. So for reading a data to a Jupyter notebook, we have to use a pandas function. So doing the same with pd.read csv, providing the file path and then providing the file name and then .csv and running. And then after running, we have a get output that this is my data, how it looks like. It is a dynamic data set. So we have a passenger ID survived, column as passenger ID survived, P class, that is for passenger class, and the name of the passenger, then what is the gender of my passenger, and then the age, the sibling, and how many the sibling and spouses were traveling in the Titanic. Then what are the parents and children that are boarding to the Titanic. Then what is the ticket number. Then what is the fare. Then what is the cabin the passengers are traveling to, and then what is the embarked. So here I would like to focus on the embarked. That embarked has a 3 values, that is we can see it is in S, C and Q. So S stands for Southampton, C stands for Cherbourg, and Q stands for Queenstown. So after looking in a quick preview of a dataset, how my dataset look like, just assigning a variable to my dataset, that is Titanic data, and then checking for the head for the same, and then here we get as output, and then checking for the tail, that it shows the last few rows of the dataset. So doing the same for checking for the info of my dataset, that how many null columns are there, what is the count for that, and what are the data type for it. Then personally checking what is the data type for my dataset, and then checking the shape of my dataset, that is 891 rows into 12 columns, and then checking the size for my dataset, that is 10,692, and then checking all this. We are just checking how many number of passengers were in my original data. So how can we get the how many number of passengers are in my dataset? So just by providing a length function to my dataset, we can get how many passengers are there to my in my dataset, that is 891. After doing all this, checking all the informations, all the passenger details, how many number of passengers, the second step is to analyze the data. So here we will analyze some of the visualizations on top of that. So here I am visualizing the count plot. So I just want to know that how many survived and how many didn't survive. So just giving the code for the same and providing the x equal to survived and providing my data equal to Titanic data. So by providing it, getting output as a count plot, it is giving me a count plot where I have x in my x-axis there is survived, and in my y-axis there is a count of the numbers, that how many people survived and how many people didn't survive. So here we are getting output as 0 and 1. 0 stands for the passenger who didn't survive, and 1 stands for the passenger who did survive. So we can see clearly that in 0 the most values is the number of count is 550. So 550 passengers who haven't survived, and there are few people who have survived as 330 or 350 as like something. So as moving forward, we just have another visualization, and that how that what was the gender of the passengers that who did survive and who didn't survive. So here as we can see that blue represents the male and orange represents the female, and in x-axis we have survived, and in y-axis as similar we have a count of the number who count of the number of passengers who did survived or not survived. Here mostly my blue indicates the male and orange indicates the female as same. So here we can see the majority of passengers who didn't survive was male, and here majority of the person the passenger who did survive was a female. So as 1 stands for the the passenger who did survive, and 0 stands for the passenger who didn't survive. So again checking for some of the visualization. Here all the codes are same, just giving another parameter in u equal to p class, that is for the passenger class. Then what is the class in which the passenger was traveling and they did survive, and the passenger who traveling to another class who didn't survive. So just checking for the same, providing a code, and then just changing the parameter of u equal to p class. And then here we can see in output that the p class in blue we can represent the passenger who was traveling in the first class, and the orange represents the passenger traveling in the second class, and green represents the passenger traveling in the third class. So here we can see the passenger who didn't survive was in the mostly in the third class, as compared to the passenger who did survive were in first and second class, where blue and orange represent the third and second class, and green represents the passenger who are traveling in the third class. So here we can conclude that I have get my passenger class who did traveling in which of the classes and they didn't survive, and the count of the passenger who did survived or not survived. And then again checking for some of the visualization, like what was the age of the passengers who did survived or who didn't survive. So just doing the same, providing my data set, and then in the square bracket providing the age, and then plot dot, I want a histogram plot, so just providing the histogram. And then here we can have my histogram plot. And then from this graph we can conclude that mostly there are young people who are in the age of 0 to 10, and we can say there are children with the age of 0 to 10. And then moving ahead we have average age of a people, and then moving ahead there will be the lesser will be the population age of the passengers as going forward to it. So here is my another visualization that I have visualized on my dataset. According to my dataset, just providing the fare in my parameter as like a parameter. So just another providing another parameter like bin equals to 20, and providing the fixed size. So here it is. And then doing same for the sibling and spouses, that here is my data set, that is mostly the number are in mostly the higher the value is in 0, and then there we have some of the values in 1, and then 2, 3, 4, and then so on. So again doing the same for the parts, that is for parents and children. So they are mostly the values is in 0, that we can conclude that there were no parents and children aboarding to the Titanic. So doing all the visualization, the third step is for the data wrangling. So in data wrangling we can compute the all missing values, null values, dropping the none values. So doing the same for it, then just checking that what are my null values, and doing a sum of that. So here we can have the age has 177 null values, and the cabin has 687 null values, and the embarked has 2 null values. So after getting the null values, we can actually drop the column that we don't want, or that is an unusual column that we don't want to visualize on top of that. So dropping the cabin and providing the axis equal to 1 and place equal to 2, it will drop. So just checking that it has been dropped or not. So just providing a Titanic data dot head. So here as we have successfully dropped the cabin. So checking another doing a data wrangling, that is dropping the null value from all the data set, then doing the same for Titanic data dot drop NA, that it will drop all the null values for it. Then just checking that it has been successfully dropped or not. So in code 22 we can see that all the null values has been successfully dropped, and we are just left with the 0 null values here. So doing the same, then again checking the data dot head. As we can see in name there is some of the string values, and while performing a logistic regression it don't take string as an input, so we need to convert it into a categorical value that is being mapped, that is being survived for the 0 and not survived as 1. So just getting a dummy data for it, that is by providing the code, that is pd.getDummy, providing a data set, and then providing the gender, that is sex, and and then just getting the output for the same, that is we are getting the female and male. And here we can see that if it has a 0 in female and 1 is a female, then it is definitely a female male, and where it is 1 as a female and 0 as a male, then it is definitely a female, and then whenever there will be 0 0, then it will be definitely a female. So we don't need these two columns, as only one column is more sufficient to tell us that whether it is a male or whether it is not a male. So just for doing that, we are assigning a variable that is equal to gender, and then pd.get dummies that I need data providing my data set, and then in the square bracket providing the gender, and then drop first and then equal to true, and then just checking for the data.head, that is five values that I want for it. So here we successfully dropped the first value, as it is more sufficient to tell us that what is the gender of the passengers traveling in the Titanic. So here it is 1, that is for male, and whether it is a 0, then it is a female. So while doing that, we can also do it for the passenger class, that is providing a new variable, that is PCL equal to pd.get dummies, then again doing the same for getting a dummy data for the passenger class, providing my data set, and then providing the column name, and then dropping it as equal to true. So here we can see whether the passenger class, whether it is in 3, the value is 1, so it is traveling in the third class, and whether it is 0 0, then it is traveling in the second class. So as doing for the same, we have also done for the embarked column, that is embarked, we have as seen we have a three variable, that is S, Q and C. So just getting a dummy data while to perform a logistic regression on top of that. So all the codes are being just same, just providing another parameter and with a dataset that is embarked, and dropping the first value that is equal to true. So whether the value in S is 1, so it is traveling for the Southampton, and whether the value is 0 0, then it is traveling for the Queenstown. So again doing for the same, now we have made all the values as categorical, after converting all the values as categorical value, that is being 0 and 1. So we need to concatenate all these rows or columns into a data set. So while doing this, getting a Titanic data equal to pd.concat, as we have to concat all the categorical value that we have mapped in between 0 and 1. So providing a data set, and then providing the columns name that we have done on top of that. So there is gender, there is embark, there is a passenger class, and then x is equal to 1, and just running that. After running, we just check our titanic.data.head, that will give. Then here we can see that we have successfully concatenated all the columns that we have converted into a categorical value, that is male, whether it is a male or not, whether it is male or female, then whether it is traveling for Queenstown or Southampton, and then whether it is the passenger classes in first class, second class, or the third class. So after doing this, we have dropped all the columns that we don't want it. So dropping the passenger ID, dropping the passenger class, dropping the gender, dropping the sex, dropping the embarked, name of the passengers, then the ticket, as we don't want it, that is the unusual column that we don't want to predict. So dropping all these columns. So after dropping all these columns, just we have checked that whether we have successfully dropped that or not. So just checking with the data.head, as we have successfully dropped, and we have a new data set with us, that is we want to predict on top of this. So we have survived column that has been mapped in 0 and 1, age is there, then the sibling spouse is there, that is being 0 and 1, the parts is 0 and 1 also, that is the parents or children, then the fare is there, then male is there, that is being 0 1, whether it is a male or female, and then similarly for whether it is traveling for which of the country, that is the Southampton, Queenstown, or the other country that is, and then we have a passenger class that is in 2 or 3. So just doing for the same, and then we have left with our fourth step, that is for training data and then testing the training data. So while providing a training data, we have first we have to do that, we have to categorize the x and y. X and y are our dependent and independent variable that we need on top of that to perform a logistic regression. So while what we have to predict that what are the passengers who have survived or not survived. So we have taken this into x, and then what is left with our data set, all the columns we will take in x, that is our independent variable. So dropping the survived column and taking all the columns into the consideration. So here we have printed our x, that how our independent variable looks like. So here it is all my data set for the x, and then checking for the same for our y. Then we have seen y is our survived column, so whether the person has survived or not survived, it is being mapped in 0 and 1. So after doing this, we have to import a test and train model. So importing a test and train model, we will import from the sklearn model selection, that is for import test and train split. Then again, after importing this, we will just provide x train, x test, y train and y test, and then equal to, and then test train split, and then provide our independent and independent variable, and then providing the another parameter, that is the test side, that is 0.3, that is in 70-30 ratio, and then the random state equal to 1. Random state equal to 1 will give will take a same sample size all the time, and will give output for all the variables according to it. So after giving this variable, so we will again import a logistic regression. So importing a logistic regression, we can do it from the sklearn linear model dot import logistic regression. So it will import our logistic regression, and then we will provide our object and class for it, then providing object as a log model, and then providing a class for it, that is the logistic regression. So after providing a logistic regression of creating object and its class, we will fit the model into x train and y train. Then we will just provide the log model dot fit, that is our x train, providing the x train and providing the y train as well. So it will fit the model, and then after fitting the model, we will just predict our x test, that how it is being done. So there is a prediction equal to log model dot predict our x test. Now we want to, as they want to make a prediction and passing the model into it, and after passing the model and running it, so here we have now to evaluate how my model is performing. And then after importing a module, we have to check that how my model is performing. Either we can do it by our classification, do it by calculating the classification report, or either we can do it by calculating the accuracy report. So while performing the classification report, while checking for the classification report that how my model is performing, we have to just where we have to just do it from a sklearn dot matrix import classification report. It will import our classification report, and then checking for the same, providing the classification report, and then providing the parameter as y test, that what we have to predict and the predictions for it. So in the output here, we got the precision, we got a recall, we got a f1 score, and we got a support. So here we can call that the precision is our 72, 72, 72, and the weight model is, so it is not bad, it is actually giving a 72% classification report. So after then again checking for the accuracy check, in order to calculate accuracy, we can also check from a confusion matrix. So giving a brief description that what is a confusion matrix. Confusion matrix is a 2 by 2 matrix that gives outcome as, that gives 4 outcome, that is actual no, actual yes, and predicted no and predicted yes. That is in other language it is also called as true positive, true negative, false positive, and false negative. Here we can check the accuracy by just multiplying this 102 and 63 and then dividing it by all the 4. We will get our accuracy report, that what is our accuracy and how the model is behaving on top of that. So just importing the accuracy score. So we will do it from sklearn.matrix import accuracy score. Then we will just provide accuracy score and provide which we have to predict. We have to predict the y test, and then for the prediction as well. So after running it will give me as a 0.77 as my accuracy score. So it is actually a good value that it is giving for accuracy. So this is all for today. Have a good day and happy learning. Thank you.